Hi everyone, so this video is going to be about one of the methods for figuring out the equation of a line. So this method is most applicable for when you are wanting to put the equation into general form, because just naturally by way of how this method works, it will get your equation into general form. You can always rearrange it once you have it in that form, but this method will take you to general form. So reminder, general form is ax plus by equals c. So that's your general form. And again, reminder, gradient intercept form, y equals mx plus c. So the convenience of the gradient intercept form is that you have two pieces that actually have meaning. So m, again, is your slope or your gradient, and c is your y-intercept. And there is an extension of that to general form, but it's not quite as clean-cut as it is in gradient intercept form. So what I want to do is kind of work an example and see if we can figure out where the slope is going as we sort of switch from one form to the other. So I'm going to take just a random equation of a line, y equals 3 over 4x plus c. So it doesn't matter what c is, c could be anything, and we're just going to kind of plug it in and see what happens. So if we rearrange this, the first thing we would probably try to do is maybe multiply everything by 4. So then that would give us 4y equals 3x plus 4c. Great. Okay, and then if I continue rearranging, I'm going to subtract 3x from both sides, and I arrive at negative 3x plus 4y equals 4c. And I said that with general form, you never want to have your x as negative. So the last thing I'm going to do is multiply everything by negative 1. And we end up with 3x minus 4y equals negative 4c. So again, this piece on this side, it doesn't matter what that is. It's just c, capital C, not the same as lowercase c in the gradient intercept form. But look where the 3 and the 4 went. So my slope was equal to 3 over 4 from my original equation. So look where the 3 went. The 3 showed up as the coefficient of x. The 4 showed up as the coefficient of y. And we ended up with a negative here in between them. Okay, that's kind of interesting. If you did the exact same thing with a negative slope, what you would have arrived at, so let's imagine we did the exact same thing except our slope was negative 3 over 4x plus c. If we rearrange, what we would have discovered is we would have ended up with 3x plus 4y equals c, whatever c turned out to be. So what you need to remember is that you can get the slope from general form. It's just that you need to use both of the coefficients of x and y, and then the slope is the opposite symbol of whatever is in between them. So to kind of shortcut that a little bit, we have for gradient AB, so when your gradient is positive, the general form of the line is numerator of slope is the coefficient of x. Because my gradient was positive, I end up with a negative. And then denominator of my slope is the coefficient of b. Similarly, if my gradient is negative in the second line here, my general form ends up being positive with the numerator of my slope as the coefficient of a, denominator of my slope as the coefficient of b. So if we know that we can actually do that, then we can use that bit of information as a shortcut to help us with method 3, I think we're at now. So this is the third way that we're going to learn how to take slope and a point. You still need those two things, always and forever, to figure out the equation of a line. We're going to take those two bits and we're going to use them to figure out what is the equation of this line. So if we look at part A, we're given a gradient of 3 over 4 and we're given a point of 5, negative 2. So if my gradient is positive, I know that I am using the negative in the middle of my general form. So how I'm going to do this, I'm going to take the numerator and the denominator of my slope, and that's going to be one side. And how I'm going to figure out the other side is I'm going to take the x and y from my point and plug it in with those slope values that I just put in. So then the other side ends up being 3 times x, which is 5, minus 4 times negative 2, which is y. And then that's what I'm going to use to figure out c. So I've got 3x minus 4y equals 15 plus 8. So 3x minus 4y equals 23. Okay, so let's recap what we did. We took numerator and denominator of our slope, plugged them in on the left with the x and the y. On the right, we used numerator and denominator from the slope and the coordinates from the point as my x and y, and then use those to figure out what is capital C on the right-hand side. So we can do the same thing with B, except this time I have a negative gradient. So if I have a negative gradient, that means AX plus BY equals C. Because X never becomes negative. It's only the symbol in between that changes when the slope is negative or positive. Okay, so let's undo that. So A is going to be replaced with 3. So 3x plus 4 replaces B equals, and then on the other side, I've got 3, substitute in my x value from my point, which is 1, plus 4, substitute in my y value, which is 7, and then solve. 3x plus 4y equals 3 plus 28. 3x plus 4y equals 31. Okay, so that's how we take general form and use our slope to get our a and b values, and then use the slope and the point to get our c value. All right, so now we're going to turn our attention to perpendicular bisectors. So no matter what, if you're asked to find the equation of a line, you need to know two things. You need to know the slope and you need to know a point on that line. Then once you have those two things, you are open to the 3 choices you have available to you to figure out what the equation of the line actually is. So a perpendicular bisector could be a delivery tool for how to figure out what those two things are. So first of all, you need to know what a perpendicular bisector is. So if we have a line segment, perpendicular obviously means we're crossing it at a right angle, 90-degree angle. And then bisector means it's cutting it exactly in half. So at the exactly half mark, you have something cutting that line at exactly 90 degrees. Okay, so if you're asked to find the equation of the perpendicular bisector, you know that that point on the line, despite what this diagram looks like, cuts this exactly in half. So this is actually the midpoint of that line segment. So the point that we're going to use is the midpoint. And the slope is going to be the negative reciprocal of the line segment. Because remember, if this is cutting at a 90-degree angle, then those two lines are perpendicular, obviously, by the name. So perpendicular lines have negative reciprocal slopes of one another. Okay, so let's walk our way through a question like this. So find the equation of the perpendicular bisector of AB for, and then we're given the coordinates of A and B. So again, remember, you need to figure out a point on the line, and you need to figure out the slope of the line. And then once you have those two things, then you can do the equation of the line. So whether you do point or slope first doesn't really matter. So I might actually erase this and save it for the next page. Okay, so if I want to start with the point, remember we said that if this is the perpendicular bisector, it's cutting that line segment in between those 2 points exactly in half. So that means what we're going to have is the midpoint is going to be the point that is also on the perpendicular bisector. So remember midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. So again, labeling off our points, x1, y1, x2, y2. So plug those all in. So -1 plus 3 over 2 and 2 plus 4 over 2. So our midpoint is -1 plus 3 gives me 2 over 2. And 2 plus 4 gives me 6 over 2. Simplify that to be 1, 3. So this is the point that exists on our line. Now we need to figure out the slope of the line. So again, the slope is going to be the negative reciprocal of whatever the slope is of the original line segment. So we begin by finding the slope of the original line segment. So we've got 4 minus 2 over 3 minus -1. 4 minus 2 gives me 2. 3 plus 1 gives me 4. So the slope is 1/2. So that's the slope of the original line segment. Original line. So if I'm looking for something that's perpendicular to that, then it's going to be the negative reciprocal of that, or -2 over 1, or just -2. Either would sort of be appropriate. This will be more useful in the next part. Okay, so now we've got a point and a slope. Now we can go ahead and find the equation of our line. For practice sake, I'm going to use the method that we just did previously in the video. So what do we have here? Point of 1, 3. And slope -2 or -2 over 1. Okay, so I've got my point, I've got my slope. Now I'm going to go with the general formula. So my slope is negative, therefore this will be ax plus by equals c. So I've got a is 2, x plus b is 1, y equals, and then on the other side I will have 2 times the x coordinate plus 1, oh, let's not do that in red, 1 times the y coordinate, and then simplify. So 2x plus, I wouldn't usually write a coefficient of 1, so just 2x plus y equals, and then this becomes 2 plus 3, so 2x plus y equals 5. So that is the equation of the perpendicular bisector that went through the original A and B line. Okay, so let's review what we've learned today. So we did some preamble about equations of straight lines, talked about general form versus slope-intercept form. We rearranged an equation to figure out where the slope went when it transformed from slope-intercept form to general form, and discovered that you can use the gradient, plug it in where A and B is, and depending on whether the gradient is positive or negative, there will be the opposite symbol in between AX and BY, AX always being positive, remember. Then we did a couple of examples where we plugged in our slope as A and B, and then solved out the other side to figure out what C was. Then we talked about perpendicular bisectors and what they are. And then we figured out how to find the equation of a perpendicular bisector by figuring out the midpoint, figuring out the slope of the original line, transforming it by taking the negative reciprocal to figure out the slope of the perpendicular bisector, and then did the method from previously in the video to figure out the equation of the line in general form. And that about does it. Thanks so much.